components are, what the architecture is, also a little bit about what is licensed with what is not licensed. Then we are going to switch switch gears a bit, and we are going to learn how to configure the process server, how to configure the server. Now, that is a fairly large topic. There will be a lot of hands-on labs to do that. If you open your computer, you can find two books in the drive C. One book let me find it for you. In your drive C, you can find a folder which names training.
Okay.
Can you find that?
No.
No?
Training.
Yeah.
Let me open my virtual machine. That takes some time.
Oh.
It's not here.
Student database.
This. This. Open your drive C, and you will find a folder named training. Then you can find a folder named training material. The class this week is the EXP 002, and there are two books in this folder. One named EXP 02 R431 blah 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 student, and another is your library book. Do you all get it? Okay. Yes, this two book is our training material. Our training material, there is one book, we named it the library book, and in it there are many experiments for you to understand this system, and we will going to there will be a lot hands-on labs to do. And we are going to configure the server to talk to a SCADA type controller. And one thing you are going to learn right at the beginning, when you are talking experience, there are really only two types of controllers. There is the process controller. Let me ask, do you have which type of your controller? C300 or C200?
ต้องซื้อสองแล้วก็
300 or 200? Do we have some C200?
200 อ่ะ
You have 200.
300
C200. 300. Because 200. Okay. I know. There is the process. Either C300 or C200. We call them process controller, and there is all other controllers made by various manufacturers, not from Honeywell. We call it SCADA controllers. We are going to concentrate in this course on setting up a connection to a SCADA controller. That means the controllers from other manufacturers. We are going to use the Modbus simulator, but the good news is, once you understand the mechanism of mapping the server to that controller, the same mechanisms would apply to other type of SCADA controller. After we set up the connection, we are then going to go in and set up optimization, set up effectiveness of for the server, and we will deal with things like server-wide alarm settings, scope of responsibility, or operators. We will deal with reports. We will deal with organism and various items along those lines. We will then talk about how to use experience data in other applications. We are going to concentrate on Microsoft Excel, but there are other applications we can talk about as well. Then we are going to talk about how to integrate Experian PKS to OPC, both as client and a server. At the end of this course, we will have some optional lessons which you may choose to view if you are interested in this particular topics. One topic is integration of Experian with a TPS system. Do you know TPS? Do you know TPS system?
No.
It's the last generation of DCS from Honeywell. The one before PKS. And we will discuss the configuration of an Experian server TPS, known as EVST, and the configuration of Experian station TPS, known as an EST. Both an ESVT and an EST are connected to the local LCN local control network of TPS system. Another optional topic is the integration of Experian and the Uniformance PhD. Uniformance PhD is the long-term historian for the Experian system. Now, who should attend this course? Anyone who is going to be responsible for configure the system. That might be engineers or application engineers who configure the server, or maybe just make changes to existing server configurations. And then anyone whose job function is to deal with the server configuration. Now in this course, we are going to learn a lot of different topics, and let me just go through a few of those now. We are going to start off with the role of the major components of Experian PKS. The architecture, how data flows. This will be information that you would need to know to plan out a system. We are going to use a tool called Configuration Studio. This is the tool that we are going to use to do the entire server configuration, and to configure the server, we are going to learn about various components. One of them will be station. Stations have three different variants. They are flag station, console station, and the console extension station. We will understand the configuration of roles. We will also understand how to map to a SCADA controller using Experian, which include three basic components: channels, controllers, and points. We will then go ahead and make the server effective for process control, and we will wrap up by talking once the server is up and running how to use Experian data in our application. We will learn how to share data among Experian servers using distributed system architecture, which we call it DSA. We also learn how to do data exchange with applications including Microsoft Excel. We will learn how to configure various types of Experian OPC clients in order to connect to OPC servers. Optionally, if you are interested in this topic, we will cover the integration of TPS system into Experian. Now there are something we will not cover. In this course, we will not cover. One of them is C200 or integrated controller implementation. C200 and the C300 configuration. The contents will not be covered in this course. Maybe in the next week course. Also, we will not cover the implementation of the C300 controller. We will not cover the HMI web display builder, the graphics. We will not cover ACE implementation, and we will not get into system administration to any great deal. And the reason is we have course for those topics in automatic college. They are more involved than we can cover in 1 week because we have 4.5 days. So there are no more time to talk about that. Those course is organized into two major parts. We are going to start off with an overview of Experian. We will talk about all the different components and that go into an Experian system. We will deal a little bit with station, navigation, and all the configuration tools that we will be using during this week. This portion will include computer-based lesson, like the one you are listening to, and there will be an assessment to reinforce key concepts. Now, normally, when someone hears the word assessment, we might think of a test, but these are not pass-fail situations, but they are just designed to reinforce the key set. That means our experiment. In the second part of this course, we will have hands-on workshop where we will configure the Experian PKS server and that will be the lessons that are computer-based, but it will also have hands-on lab exercises. We will alternate between the lecture and the experiment. Lecture first, and after the lecture, you can do your experiment. And each of those topics will also have an assessment for reinforcement. Now this picture shows our schedule in this course. At the first day, we will introduce system architecture, C300, and asset configuration and flex station configuration. Tomorrow, we will talk about quick builder and SCADA connections. There is many experiments for this topic, and so this one topic will have 1 day to discuss. And the third day, we will talk about history key options, and the groups and the trends and event key options. The third day. The last day, we will talk about alarm shelving and alarm groups and alarm suppression and finally alarm tracks. The contents we introduce in this class is the main part of the whole course. As you can see in your training material, there are some other contents, and we may introduce some of other contents after all these main points finished. After all these main points finished, we maybe introduce some other contents. And you can also study them and try to finish the other experiments after class. You are now complete with the introduction. We will start with the first component of the course. We will get into some planning information, starting off with system architecture. When you are ready to do that, pick the first lecture from the menu and start the presentation. Now let's open your training material, which named, sorry. Open up your training material, which named this one. And open to page 17. Page 17. Wait a minute. Okay. The first lesson. This lesson introduces you to the different components that make up experiment. At the conclusion of this lesson, you will be able to identify the basic components and the connections, and You will also be able to explain the general purpose of the components and the connections. We will get into more detail on all these components later, but the idea here is to give you a basic understanding. The slide shows an experience system that has many different components. The picture is important to display the different components of the system. Let's start with the component that is the center of the experience system, the redundant server here. It's the center of the experience PKS system. The server does not have to be redundant. It is optional. That means you can have single server or a redundant server, a pair of redundant servers. But the server contains the real-time database, the first important database, real-time database. Let me write it to you. Okay, here, RTDB, real-time database. The server contains the real-time database, also referred to as the global database. The real-time database of the server comprises of all the components, including the controllers and the stations we all discussed further. It is a global database and contains all the data. Here, you will note that in this diagram we have a couple of servers. One of the reasons being, as shown here, that the C200 controller can be connected by two different ways, by using FTE, by using an Ethernet connection, or it can be connected by using a network called control network. So the second server, this one, the second server here, shows a C200 or a process controller connected using control net. C200E controller architecture is very similar. It's the same to that of the C200 and C200E. C200E is very similar to that of the C200 controller, with an expanded memory capability. We also have a third server in this diagram. This server is used for a specific purpose. In addition to being a fully functional experience server, it has an LCN connection. LCN means local control network. It's the control network of TPS. So this is a TPS controller. This is a TPS controller. The files shown below, the third represents the LCN. This is an ESVT. Yes, this is an ESVT, Experience Server TPS. Experience Server TPS, ESVT. The LCN connection will be the third server being used to bring the LCN information into the network. Bring information from here to the FT network. Now, all the three servers can communicate with each other. This one. All the three servers can communicate with each other. They can share their data using distributed system architecture, DSA. The DSA is a network between servers. You can have up to 31 servers in a DSA network. The maximum is 31. We are using a fault-tolerant Ethernet in this diagram to connect these things together. Fault-tolerant this network, fault-tolerant Ethernet. We call it FTE for short. What?
We can see the pointer on the screen yellow.
What?
Can you use pointer? Because we cannot see when you point in each location in your slide.
Point.
The mouse.
Pointer.
Can you show the mouse on the screen because we don't see anything when you scroll your mouse?
This is our slide. You want to see
your point, your mouse.
Move your
my mouse.
When you use your
Okay.
mouse, we can see.
Let me try. This? You mean this?
Maybe it's okay.
That's
Right
okay.
there.
Right click.
Better.
You can right click and
Okay.
You can do that.
Fault-tolerant Ethernet here. Here. It's the network of experience system. It is patent technology of Honeywell. What we have done is we have taken Ethernet and we have improved it for process control. We have made it more robust, and in instance, we have given the different components 4 different paths to communicate with each other. If one of those paths fails, the other 3 are still available. So we will get into more detail of FTE, which is the short name for fault-tolerant Ethernet. Let's start with the top of the diagram. The top of the diagram shows the user interface side of the architecture. We will start off with this station. The station is used for operations. It does also have configuration capability, but as we are going to learn, there is a tool called Configuration Studio now, which takes place of lot of station configuration screens. Now, we are showing a very complex station here. It has 4 screens and a special configured operator keyboard. This is called an icon station. 4 screens and 1 special configured keyboard. And this station, we call it icon station. A station can be either an icon station, or it can just be a simple personal computer, your laptop or some other computer you can buy from the market. We are also shown a PC here. That is running remote engineering tools. When we configure the server database, there are different tools to be used. They all come together under the umbrella of Configuration Studio. Many times we use the PC that has the configuration tools on it as station so that we can check out the work. But we don't have to do that, so we are showing a PC that is running engineering tools. Here. We have a couple of wireless components that are valuable as options. One is a complete wireless components. One is a complete wireless station. The other one is used by maintenance personnel to gather and supply information from specific devices on the network. We also have some called the e-server here. The e-server. The e-server provides a casual user experience information. Now, the beauty of the e-server is that the casual user do not need to know the station. You don't need to install the Experian PKS station software on your computer. You only just need a web browser like IE, like Firefox. The same screen that an operator would use will be available to you when you open it with your web browser. However, they are available in a read-only format, and that means you can't operate through your web browser. You must do some operations in your station. You can only read, you can only see the data from the web browser. Now we have something called ACE here. This application control environment. Shown in this diagram, the device is used for advanced control. It has the same capability as the C200, with the addition of being able to write your own programs. It uses VB.NET language, so you can have fairly control with the ACE. On the far end of the diagram, we have the PHD historian. PHD stands for Process History Database. PHD, Process History Database. This is an application that runs on a separate machine. It also allows history connection for large amounts of data from many sources, including Experian, for a very long period of time. Just a clarification, we have a product called Experian PKS. The PKS portion stands for Process Knowledge System. The PKS stands for Process Knowledge System. We call it PKS. It's okay. What we are trying to do now is bring together all of our different applications, our advanced controls and out manager type applications, and also our TPS applications. We bring these all together now into one system. So the PKS is a designer of for that effort. Now let's look at the bottom part of this diagram. Where the controllers live. In Experian, the world is broken up into two basic types of controllers. One type is integrated type. That means the C200 or C200E or C300. The C200 controller is the C200E is an advanced version of C200. These controllers are the first type. We call it integrated controller. The second type is SCADA controllers, as shown here. SCADA controllers. The differences is in this, the C200 or C300 controllers were created with the Experian server in mind. It's a member of our family. The C200 and the C300 is a member of our Experian PKS family. They are fully integrated with the Experian server. When the C200 or C300 database is configured, the download also loads the Experian server global database, means RTDB. So it is a one-step operation. With the SCADA controllers, they can be made by Honeywell or many other manufacturers, not Honeywell, for example, AB or Siemens, something like that. We use a configuration tool supplied by the manufacturer to create the controller database. We then use Experian to create a mapping database for supervisory control and data acquisition. That's why we call the SCADA controllers. If we take a look at the C200, one of the benefits of that controller is it has many different families of I/O modules. There is a 64 I/O unit limit. If you stay within that limit, you can mix and match the different families into the same controller. So in our diagram here, we shown chassis I/O made by Allen Bradley, AB. We are showing real I/O, also made by Allen Bradley, AB. We are also showing foundation field bus. We are showing foundation field bus. Some devices. Field bus. We are showing Profibus. That's designed by the Siemens. And we are also showing DeviceNet. One additional I/O family is that of PMIO. It adds the option of redundancy. All of those I/O families are available to come into the C200. The C300 also supports a total of 64 I/O units, which can be mixture of PM family. PM family here. And series CIO here. This is PMIO. And this is series C. Moving across the diagram, we have a specialized controller that is created by the Honeywell Europe group. It was created specifically for the paper industry. This one is for the paper industry. We call it PMD. It's for the paper industry. It also has the ability to use many different I/O families. Another component at this level is Safety Manager here. Safety Manager. Safety Manager. The Safety Manager system is a microprocessor-based control system for safety application. It is designed to protect safety-critical processes from runaway situation. Finally, over the far left, we have something called Digital Video Manager, DVM. Here. This is a product. It's a piece of software which use standard network type cameras, and its goal is to supply live video to the redundant server. As an operator at a station, you can call up the graphic that has the live window into something happening in your process. The DVM was created to the efficient in its supply of live video to the server. Through it makes optimal use of the bandwidth available. It also does not supply feed continually. You can configure it to supply video on a timing-based or also a motion detection basis. So it was designed with the experience server in mind to optimize the communication. Let's summarize. We have now learned about the basic experience PKS components, which make our system. We learn that there is a server which contains the global or real-time database, and there are stations. Which give operators the ability to view and interact with the database. We've got configuration PCs which run the configuration tools. We use these machines to configure the server database. We have the device called the ACE, the application control environment. This is used for advanced control. We have something called an e-server, which supplies the same screens that are used by station to people that have a web browser. This will be Coral user because they are read-only access. We have the PHD historian, which stores long-term process history data for the experience system. We have the C200, C200E, and the C300 controllers, which are fully integrated with the experience server. And we've got SCADA controllers, which are made by Honeywell as well as many other manufacturers. These controllers are configured using some other tool besides Experian. We use Experian to map for supervisory control and data acquisition. We've got the DVM, which supplies live video to the station and operator screens. And we finally hook everything together using fault-tolerant Ethernet of FTE. Now, referring back to the diagram, if a component is going to be an FTE component, it has to be able to run the software that controls the FTE. SCADA devices normally are not FTE connected. They are connected normally with a single Ethernet. We have reached the conclusion of this Experian system architecture lecture. The next thing we will talk about is more detail on some of the components. And we will start out by talking about stations and how they connect up to the server. In this lesson, you will learn more about the Experian PKS server and also about the various